The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everybody. Thank you for attending our webinar today. My name is Dave Jacobson. I'm the Senior Application Engineer here at Lambda Research. Mike Govin was scheduled to be our moderator this morning, but unfortunately he's unable to attend, so I'll be playing both roles today. The format of today's webinar is a 25 to 30-minute presentation followed by a question and answer session. The webinar may run a little bit longer than that. I've got actually quite a few slides to show you today. At any time during the webinar, please feel free to submit questions using the question box on the GoToMeeting or GoToWebinar control panel. And we'll address all the questions at the end of the webinar. I should have mentioned right off the bat too, the topic of today's webinar is the TracePro RepTile property and the Texture Optimizer 2. Some additional resources that you can use in terms of TracePro. All of our webinars are archived on our website at the webinar section, and this webinar will be added to that list probably within the next day or so. We also have TracePro tutorial videos on our website, as well as printed tutorials that you can follow along. And you can also find information on our website about upcoming TracePro training classes. Speaking of training classes, we have 2 classes coming up very soon. And I just noticed my dates are wrong. It's actually October 18th to 19th and October 20th to 21st in Jena, Germany. And the training here in Littleton, Massachusetts, is October 25th through the 28th. And in both cases, we're going to do a 2-day introduction to TracePro class, and then 2 days dealing with optimization. So if anybody's interested in those trainings, please feel free to contact us here. We'll be happy to send you out the information. Just a quick note, latest releases of TracePro. The current release of TracePro is TracePro 7.7.2. But also we do have TracePro 7.8 available as an early access release. So anybody that has a current maintenance and support agreement can download these new releases on our website, and we encourage you to do that. So let's get started with today's webinar. As I mentioned, the topic is the TracePro RepTile property and the Texture Optimizer 2. The agenda for today is, first of all, we're going to talk about, well, what is the TracePro RepTile property? Then we're going to jump in and spend the rest of the time on the Texture Optimizer. So what is an overview of the Texture Optimizer 2, the types of textures that are available to be optimized, setting up the Optimizer 2, and I'll walk you through step by step with an example, the optimization process. And then we'll wrap up with just a quick little section to show you how you can use the Texture Optimizer to apply texture features to curved surfaces. And then we'll wrap it up with the question and answer session. And as I mentioned before, and I'll try to mention this a few times during the webinar, please feel free to submit questions at any point during the webinar. So let's start off with talking about the TracePro RepTile property. First off is, what is RepTile? Well, RepTile stands for repetitive tile, and it's used to define repetitive microstructures in a convenient way. For example, the light extracting features on the back of a backlight or a light guide. It's a mathematical representations of the repetitive structure. It allows for smaller file sizes as well as faster and easier modification of the structure. And RepTile properties can be applied to planar or flat surfaces only. The region of the RepTile, it's bounded by a rectangular, circular, or surface boundary. And many of the geometry types are available either as hole or bump. And I'll explain that here in a few minutes. And then one last note is RepTile and the Texture Optimizer 2 that we're going to talk about shortly both require the Expert edition of TracePro. So if you wanted to define a RepTile property, you can go to the RepTile property editor. It's at Define, Edit Property Data, RepTile properties. And again, this is only going to show up if you're in TracePro Expert. Here's a simple example of a RepTile. We have whether it's a bump or a hole. And again, I'll show you that here in a second. The tile size. In this case, this is a 2mm by 2mm tile. What's our geometry type? A sphere. And then the feature dimensions. And these feature dimensions are going to change depending on the geometry type you've selected. In this case, for a sphere, we have a radius and a depth or a height as our options. So in this case, it's going to be a 0.5 millimeter radius and a 0.5 millimeter depth or height on a 2 by 2 millimeter tile. Here, this is maybe slightly difficult to see due to the colors, but a bump would stand proud of the RepTile surface, and a hole would be a dimple on the surface for, say, a sphere, so like a golf ball. And you can switch those two and get different effects. When you're applying the RepTile in TracePro, it's in the Apply Properties dialog box. We would select RepTile. We can pick the RepTile name, and we can have catalogs and individual names. You can apply a surface property to the RepTile. So in this case, we're applying to this dot would be diffuse white property. And here's the boundary. In this case, this is the boundary on the surface that's applied to. So this is using surface bounds, so it would allow us to apply it to the entire surface. But there's also options for rectangular and circular. And as I just mentioned, that the RepTile can have a surface property, and it can use any surface property in the TracePro database. So it could be diffuse white, it could be colored paint of some type, could be a roughened surface using a scattering property, could be a mirror property. If you want to display the RepTile, and by default, in order to save graphics time and processing time, the RepTiles are not displayed. But if you want to see them, you just simply go to View, Display RepTiles, RepTiles and Boundaries. And there's that RepTile we just made, the 2 by 2 millimeter tile with a 0.5 millimeter radius sphere on it. Here's what happens if we increase the boundary size. So now we're tiling it across the entire surface. So we went from here just showing you have the option you can do a single tile. You can cover the entire surface with it. You could cover a certain portion of it. You could very easily go in, and this is one of the nice things about RepTile, we can come in and change the feature dimensions. So we don't have to rebuild the whole model. We can just edit the property. For example, change the radius to 1 millimeter, the depth to 1 millimeter. And here we see now we have larger dots. We didn't have to go back and rebuild the whole model, just edit the property. Another advantage of RepTile, as opposed to modeling objects like this physically, is it can save a lot of memory and make for much smaller file sizes. So here was a surface with a micro lens array on it. And in this case, this array wound up, there was over 6,800 objects. And it was a 16 megabyte file. Ray trace times would be longer. And if you want to change the parameters of the lens structure, you have to rebuild the whole model. With RepTile, it's a 17 kilobyte file. It's one object. And if you want to change the parameters of the lenslets, just edit the RepTile. You don't need to rebuild the whole lens array. Here's a list of the available RepTile geometries in TracePro. And this list grows pretty much with every release of TracePro. But to go through it, Fresnel, cone, sphere, ellipsoid, hip or mansard roof, cube corner, prism, rounded prism, log, enhanced prism, flattened cone, pointed cone, DMD, block, chiseled log, torus, A-sphere, and polygon. And if you go into the TracePro manual, you can find examples and all the information on each of these types. And as I mentioned, this list is updated quite frequently. In addition to the object or the parameters there, the feature types, You can also change the variation, how the reptiles vary across the surface. Constant, where you enter data for one tile and it's repeated or replicated across the surface. Variable, ring, or row, you enter data for all tiles in a row, and then each row has the same tiles. Parameterized, you enter a formula for each geometry dimension and tile dimension. So you can write a mathematical formula to vary the tiles as it goes across the surface. And then lastly, texture. And a texture file is each geometry feature is placed freeform by entering the coordinates and dimensions in a text file. This texture file is what we're going to be looking at quite a bit when we get into the Texture Optimizer 2. This RepTile background is kind of building as a base for the Texture Optimizer. Here's an example of the parameterized RepTile. We can see we have tile parameters here, and then we have equations that reference the rows and columns, and the radius and the height are a function of the row and column. And in this case, the reptiles get bigger, the spheres get bigger as you move towards the center of the block. There's also a selection of tile types. How do you want to array the reptile tiles across a surface? And we have rectangular, hexagonal, staggered rectangle, ring, and staggered ring. So a lot of different options as well on how you want to array those reptiles. A couple quick screenshot examples. Here's an LCD backlight with no texture applied to the surface for light extraction. So there's a fluorescent tube here, there's a light guide, and we have a target above there. And what you can see is that most of the light is extracted right on the end of the light guide where the lamp is. So very non-uniform illumination. If we apply a RepTile to that surface, rerun the ray trace, you can see we can get much more uniform illumination. In this case, I believe the RepTile is nothing more than a hemispherical dot replicated across the surface. Another example of a use of a RepTile is a microlens array. Here we see the microlens elements modeled as RepTile features, and then just running in this case, a grid ray trace through there, and we can see each microlens focusing the light down to a separate point. So you can use that as well, and then you could go in and vary. They may not even be limited to spherical. There's an aspheric option for a RepTile as well. So I want to spend just a little bit more time here also talking about the RepTile texture file. And the advantage of a texture file is it allows the user to define the location and feature type explicitly. So you're individually defining the features, their types, their locations, and you can do that for each and every feature on the RepTile surface. It allows for mixing and matching of feature types. For example, a combination of spheres and cones could be defined. And I have a screenshot showing that here coming up in a slide or two. The allowable geometry types at this point for the texture file: sphere, cone, hip roof, ellipsoids, enhanced prism, log, flattened cone, pointed cone, DMD mirror, block, chiseled log, torus, and polygon. Just a couple of those there. The DMD mirror is the Texas Instruments digital micro mirror device, where using the RepTile property we can model those individual micro mirrors and set the angle of tilt. And you can do that, and you can actually have a utility that allows you to use a bitmap image to set the tilt to reproduce an image when you're modeling a DMD micro mirror device. Block allows you to actually insert the objects using a texture file in 3 dimensions. So you can have blocks at different heights throughout the surface. And again, these can be bump or hole, so they can be inset to the surface or proud of it. And for full description, please see the TracePro user manual starting in Chapter 7, page 108. Here's the example of it, or an example of a texture file. First column here, and this is just can be opened and edited in a text editor, Excel, or any program like that. Here's the texture feature. In this case, feature type 3 is a sphere, feature type 2 is a cone. Here's the bump sign, it's called. Is it a bump or a hole? In this case, a -1 means it's a hole. The center position in X, the center position in Y, and then the feature parameters. And the features that are going to be entered here are going to vary depending on the RepTile feature selected. So for example, a sphere basically has radius and depth, whereas the cone is going to have radius, depth, angle, and I think radius for the top of the cones, a couple other parameters there. When you want to use a RepTile, when you want to use a texture file, what you do is when you're defining a new RepTile property, for the variation type, you choose texture file. And then you browse to the location of the texture file where you've saved it. It's just a .txt text file. Makes this up. So you tell TracePro where that is, and then you can apply it. So example, this is just applying an example here. And here's the RepTile that's actually made from this mixture of spheres and cones applied to a surface. So we have some spheres, 1, 2, 3, 4, 5, and then some cones here. So just a way to look at, you can mix and match if you wanted to. So to summarize RepTile, it allows you to create repetitive microstructures quickly and easily. Numerous geometry types are available. There's several variations are available for tile positioning: staggered rectangle, rectangle, hexagonal. Model sizes are greatly reduced, and ray trace times can be faster. Geometry is easily changed by editing the RepTile property file. And then the texture file allows you to explicitly define feature types and location, and allows for a mixing and matching of feature types. So with the background out of the way, I'd now like to talk about the Texture Optimizer, the Texture Optimizer 2 actually in TracePro. Previously we had a Texture Optimizer. Probably around a year or so ago we introduced the Texture Optimizer 2, which greatly expands on the capabilities of the previous Texture Optimizer. Also, at least to me, I find it's much easier to use. As I mentioned too, as we're going along, just another reminder on questions. Anytime you have a question, please feel free, just type it into the question box on the GoToMeeting control panel, and we'll look at all questions at the end. So what is the Texture Optimizer 2? Well, it's included in TracePro Expert in the Optimize menu, and it's used with the RepTile property in TracePro. It allows the user to define the surface boundary for the RepTile, the surface partitioning, how's the surface divided up, how are you going to fill those cells, those partitioned cells with RepTiles, and then what's the RepTile feature type. The surface boundary can be defined using the name of a surface in TracePro. So this allows for complex surface boundary shapes. We're not limited to just a rectangle or a circle. And the example I'll show you can see has a somewhat complex shape. The surface partitioning options include uniform, grid, and ring. There's also numerous options for filling the cells. And that's how do we distribute those RepTile features within the cells. And currently we have 12 different RepTile features available for use in the Optimizer. And lastly, the Optimizer is divided into two main parts. The dot generator, which is where we'll create the RepTile. We'll partition the surface, create the RepTile, and fill the cells. And then the optimization window, where we'll actually set up the parameters to run the optimization. So it's just a little bit of a walkthrough through some of the different parts here. Here's the dot generator window. And when you open the Texture Optimizer, Again, it's in the Optimize menu in TracePro Expert. This is what you'll see, the dot generator. First step normally is setting the boundaries, and that's up here, the upper left corner. You can click the drop down for the boundary and choose rectangle, circle, file, ring, surface, or surface UV. Here's just some examples from that. Here's a rectangular boundary in the upper left, circular, ring, or surface boundary. And in surface boundary, we give the utility, the texture optimizer, to the name of the surface we're going to use as the boundary. And you can see here, this is the light guide example we'll look at as we go a little bit further. We also have several options for partitioning that space, so that surface, uniform, grid, ring, or using a density map. And here's just, again, some quick examples there. Here's a uniform distribution, here's a grid, and here's the ring method. You can also choose how do you want to fill the cells with the dots, with the RepTile features. And you can see we have, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, about 20 different options there. And here's just a few of them set up. Here is assign density uniform, assign density is a grid, and assign density in a hexagonal pattern. So again, we can vary how are the dots distributed within a cell. And then the dot shape options: sphere, cone, hip roof, ellipsoid, log, pointed cone, flattened cone, A-sphere, torus, enhanced prism, polygon, and model. And the next section here, I'll show you just some quick images of what each one of these looks like. Also in the dot shape section here, when you define the parameters, you can turn on dot preview. So you can see a little three-dimensional drawing here of what's the dot going to look like. So you can make sure you're putting in valid geometry. You can turn the dot display on and off. It's a little checkbox here for dots. And you can also come in, once you've set up your model, you can come in and click under Action, Optimization. And then that's going to open the optimization window. And again, the next couple sections I'm going to get to, I'll walk through step by step how to do an example with this. And after the webinar, I will include the files on our website. So if anybody wants to use this as a tutorial, they are more than welcome to. So let's start to dig a little bit deeper. Let's talk about the texture types. And we'll go through this rather quickly here. But these are the texture types. They're defined here in the dot shape section of the dot generator window. As I mentioned a couple slides ago, sphere, cone, hip roof, ellipsoid, log, pointed cone, flattened cone, A-sphere, torus, enhanced prism, polygon, and model. And I'll just show you little screenshots of what each of those is. And as you'll notice as we go along here, depending on the dot shape, the parameter options here are going to change. So here's a dot shape of the sphere. We have radius and height. If we do cone, we have height, end radius, cone angle, chamfer height, chamfer angle. A hip roof, an ellipsoid, log, pointed cone, flattened cone. A-sphere allows you to define the aspheric profile. So this could be used for dots, but it could also be used for, say, a micro lens array. We want to have an aspheric shape. Torus, enhanced prism, For example, the enhanced prism gives you a lot of different options on the angles, the radius, the trough radius, the end radius here. There's also a polygon option, so that you can define the number of sides, the height, the thickness. And then the last option is called model. And what model lets you do is make an object in TracePro. So I have a TracePro model here, and there's an object here named new dot. Just picked a random name, and it's a sort of a complex shape. I actually drew it in the 3D optimizer, then sent it over to TracePro. But we pick model, we give the model name, new dot, its origin, normal vectors, up vectors, for fairly standard things for TracePro. And then we can come up to here, up to the export menu, and we're going to export this as what's called real geometry. And I'll explain a little bit more about real geometry at the very end when I talk about applying RepTile to curved surfaces. But we can tell it where we're going to put this. It's on the surface named top. We can choose, do we want to add it to the surface using a Boolean unite, subtract it from the surface using a Boolean subtraction. And then here we see that that shape has been replicated across the surface. Now it's not true RepTile in this case because it's actually a real physical geometry. So it does have the limitations of modeling with real geometry. The number of features that you can do is going to depend on things like the RAM on your computer, and it's going to take longer compared to RepTile. But it allows you to model and do RepTile-like features with geometry that wouldn't be available in the standard RepTile menu. So let's walk through an example. And we'll look first at setting up the texture optimizer too. And as I said, I'll make these files available in the download section. When we put this webinar up, you'll be able to get the slides, the recording, we are recording this, and the example files. So you'll be able to walk through and set this up yourself. So here's the typical workflow. We build the model in TracePro, defining sources and targets, define the initial texture in the dot generator window, export the texture file and make a RepTile property in TracePro, apply the RepTile property to the model, run an initial ray trace. I always like to do that, make sure everything's set up right, test the model to make sure RepTile and a radiance map are aligned, set up the optimization parameters, run the optimizer, and then update the TracePro model and verify the results. So here's the example for today's webinar. It's a light guide, sort of a flattened ring almost, single LED. There's a couple holes in the light guide, say for mounting. And here's a target that has the same shape in this case. A couple things I've done in advance here. The bottom surface of the light guide, and it's an acrylic light guide in this case, I named the bottom surface bottom. This is where we'll be applying the RepTile. We're going to need that information a little bit further on. The LED for this example was simply a Cree X lamp XPE white 3700 to 5000 Kelvin, tracing 500,000 rays. I also have an object here named target, and the surface that's facing the light guide I named receiver. Again, these are names we'll need later on. And initially I ran the ray trace with no texture applied, and in order to really see anything other than a lot of light escaping at the two mounting holes, I had to switch to a log scale. So you can see right off the bat, this would not be a good light guide design without texture. So I'm going to go in, I want to optimize that. Here's the same thing, it's now just showing using the 3D illuminance or radiance map in TracePro. So we're going to go to Optimize, Texture 2, and open up the home screen for the Texture Optimizer. Now, because my light guide shape is a little more complex, it's not a ring or a rectangle, I'm going to use the surface itself to be my boundary. So I'm going to go to Boundary, select Surface, and then down here, I'm going to enter the name of the face. It was Bottom. Remember back here, I named the bottom of the light guide Bottom. Told you we'd need that at some point. So the face name is Bottom, the object name is Light Guide. Click OK, and it brings in that surface shape. Very quick, very easy, and lets you define, lets you use almost any type of surface shape. Now, still remember the one main limitation of RepTile is we're still dealing with flat or planar surfaces here. So now, bottom surface is being used as the boundary. Next step is I need to divide that surface up. And for this example, I chose a uniform partition with 250 cells, and then I clicked Generate. And it populates that. It divides the space up into these roughly uniform area cells, and in this case, there's 250 of them. Next step, I'm going to skip the in cell for a second here. I'm going to go over to the dot shape. And my dot shape for this example is a sphere. It's going to be a hole, so it's going to be going into the light guide. And it's going to have a radius of 0.05 millimeters and a height of 0.05 millimeters. And then the last step here is I can fill the cells. So I can fill these 250 cells with these dots. And my option that I selected was using the density and putting a uniform density. And my density factor in this case was 0.25. And sometimes this can take a little trial and error. You want to try a number, look at the results. Is it filling up the cell? Is it putting too many in the cell? And adjust accordingly. Okay. And then all I did is I turned on the dot display by clicking here, and then I zoomed in. And I can see, okay, 0.25 has a pretty good fill factor. One other thing you'll notice is that these dots are green. That's a quick check, signifies whole. If I had this switch to bump, these dots would be blue. So you can tell quickly how you're set up there. So now we've created or set up that surface with the partitioning and the infills. We need to export this to TracePro. And what we're going to do now is we're going to create the texture file that we'll use in TracePro. So simply go to Export, TracePro Texture, and give it a file name, and click Save. And the resulting file, it's a .txt text file. And again, you can save you can also at this point, it's a good reminder, you can save the Texture Optimizer 2 file by going to File, Save As. The file extension is DGF, and this saves all the settings defined in the Texture Optimizer for future use. So if you want to come back to this example in the future, you can just open that DGF file here in the Optimizer. It's also very useful if you're running into a problem and need to send a file or some information to our tech support group. You can just send them that, in addition to your model, that .dgf file. Then we can troubleshoot it. So once you've exported the texture file, in TracePro, you need to make a RepTile based on that. So we're going to go to Define, Edit Property Data, then RepTile Properties. It's going to open up the RepTile Property Editor. You can add the property to an existing catalog if you want, or you can make a new catalog. In this case, I made a catalog named Texture Optimizer 2 Webinar, today's webinar. Then I can also click Add Property, give the property a name itself, and tell it what it is. The variation type is a texture file. And then lastly, click OK. It's now going to show you here the texture property editor, the RepTile property editor. In the file box here, you can browse to the location of that texture file that you saved. Click Open. make sure it's set up. You want to set it for whole and give it sort of, in this case, it's somewhat arbitrary, but the tile parameters. I chose for this one 0.1 by 0.1 millimeters. It's a texture file, so this isn't explicitly used, but it wants to be defined. And then we can apply this property just like any other property in TracePro. Now select the bottom surface of the light guide, right-click, choose Properties, then choose RepTile. I'm going to pick the catalog that I saved it in. In my case, it was Texture Optimizer 2 Webinar, the name of the texture. I can apply a surface property to it. Say I was going to fill those dots in with a white paint. So I can say, okay, from a surface property catalog, flat white paint. And again, any surface properties you have available in TracePro, they're saved in your TracePro property database, are available here to be applied. We can set the depth. If you remember when we were setting this RepTile, the height or the depth of it was 0.05 millimeters. So there's that there. Choose Use Surface Bounds, and then click Apply. And I mentioned it earlier, but by default, the RepTile is turned off. The display of the RepTile is turned off. And you can turn it on by just going to View, Display RepTiles, RepTiles and Boundary. And here's the RepTile here. You can see it uniformly covering the surface. And if I zoom in a bit, here's our little hemispherical dots, or indents or holes. Usually I don't leave RepTile display turned on because it can make operation, rotating the model, things like that, run slower if you don't have a really good graphics card. I ran the ray trace and I looked at the illuminance map. In this case I was in photometric unit, so it's an illuminance map as opposed to an irradiance map. It's on the surface named target. So here's our initial results. A lot of the light's being extracted right here near the LED, and there's very little, if any, light getting out into the far end of the light guide. So we'd like to improve that. One thing you want to do is look at the orientation of the model here in the Texture Optimizer 2 and just adjust the normal and up vector settings in the irradiance or illuminance map so the two images match. You can see our LEDs our entrance is on the right side here. The holes match up the way they're supposed to be. So we can just adjust those up and normal vectors here to make sure they're in the same orientation. And that's important to do, especially with non-symmetric type surfaces like this. So now we're ready to start the optimization process. So let's talk about that. Let's talk about the texture optimization process. Sort of the last step in this whole Texture Optimizer 2 utility. First thing, we can open the optimization window by going to Action, Optimization. And it's going to open up a second window. And we can see here there's a lot of things already set up. We have our shape here. We can see our cell partitioning. We can choose we're doing a uniformity optimization. Now the first thing we want to do is we want to tell it where's our target surface. So if you remember back when I first was talking about setting up the model, I said I named the surface of my target object that's facing the light guide. I named it Receiver. So here I type in the name Receiver, and then I can click this green check mark, and it's just a check to make sure. It's going to say that the specified target surface exists. So it's a good way to check, did you spell it right? Did you name the surface in the model? Things like that. So now the optimizer knows to look when it's looking for the illuminance or irradiance information. It's going to know to look at the surface named Receiver. Next step, in this example, we're going to choose the distribution. And for this case, we're going to use random distribution. And random distribution means the optimizer is going to vary the density of the texture in each cell. And by density, I mean it's going to vary the number of dots in each cell. There's other methods too. We could keep the number of dots in each cell constant and vary the dot parameters. For example, for our sphere, we could vary the radius or the depth, things like that. So there's other ways to do the optimization. In this case, we're making the assumption we want all the features to be the same size. We're just going to change the number of them in each cell. You can choose what your export target's going to be. In this case, it's going to be a texture file. And then we also want to browse to the location of our initial texture file. So here it's just saved on my hard drive in a folder. I browse to it, and that fills that in. And then most commonly what I do is I use this for my initial mode is to start as initial density. So it's going to let you set an initial density, in this case 0.1, which is a little bit lower than what our texture file was. And you can set the max density. And the goal with the maximum density setting is you don't necessarily want dots overlapping. Or if that's the case, you don't want dots overlapping. You can also here in this same section define a results folder. Where are the results of each iteration going to be saved? And one of the main things that's saved in each iteration is the dot pattern. So we can go back and reuse those dot pattern, the texture files, to create RepTiles again. And you have the option as well to give it a file prefix. So for this example, every one of these files is going to start with the name webinar. And lastly, we're going to verify the dot shape. This should all come right over from the previous window, but it's sphere, hole, radius, and height. If the RepTile is not aligning with the surface properly, for example, it was flipped, and so the RepTile was over here, you have options for reversing X and Y. And then lastly, when you're ready, you click the Start button. And here's the optimization log. I actually let this run overnight. It didn't really need that long. What this will show you is the results of each iteration. This blue trace here is the error value. And just like any of the optimizers, the lower the error value, the better. So in this case, you can see it dropped down here, and then it got worse, and it continued on. And in the settings, in the preferences for the optimizer here, you can tell it, for example, what's the maximum number of iterations I want to run, or what's the number of iterations to run past the best value. So that usually defaults to 3. I extended it and said I wanted to run more than three iterations past the best result because I wanted to see, does it come back down? Is that really the best result? In this case, it was. It was after the 5th iteration. The other thing here on this map is the flux on the surface. So sometimes you may want to decide, you may do a trade-off of it's not just the lowest error function, but if your flux is varying widely, you may want to pick a different option so you get the most flux. But in this case, it was fairly flat. So our best results, 5th iteration. Here's the irradiance map for the surface with that particular one. Here's the 5th out of 30 iterations, and here's the error value. I just note we've got fairly high illuminance or irradiance and error values right around those holes. So that's something that might need to be baffled or masked off if this was a real production light guide. Here's the results that are saved. Again, this was a folder I named where I pointed to it right here. Sorry, for the results folder. So here are the results that are saved, and it's saving a density map, a dot pattern, an irradiance bitmap, the irradiance text file, and it does that for each iteration. What I'm really interested in this case, this told me my 5th iteration was the best. I come down here, webinar_5_dot_pattern.txt. That's the file I'm going to want to get. And what I'm going to do with that is I'm going to update the RepTile property in TracePro. So I'm going to go back to TracePro, open up the RepTile property editor, click the lock icon here, so it lets me edit the property. And then we can come in and choose or just browse to that new file location. So webinar5.pattern.txt, update that. And here's the before and afters. This was the initial RepTile texture pattern. Here's the optimized texture pattern. You can see we have very few, or the lower density around this part, and very high density of the dots here, a little bit higher up in through here as well. Thinking about the way the light goes in, that's understandable for that higher density pattern. Here's the initial illuminance map, and here's the optimized result. One thing I did here is these two holes were really sort of dominating the image, so I set an upper limit on the lux value just so that and let those saturate, just so we could get a better look at what the distribution was. Here's the 3D illuminance map showing the results right on the model in TracePro. Similar results. So we can see we actually did get a pretty good result for a relatively short time now of doing this. Maybe, things I could look at improving. I could add more cells. I could try a different size dot pattern or a different size sphere or things like that. I could also run longer ray traces. Is some of this noise and error due to the fact that I should be tracing more rays? But it's very, once you've gone through it once or twice, it's a very useful and easy tool to use to get to this point of optimizing these textures. And there's a lot of versatility and a lot of capability in how you set this up. So feel free, go in, experiment, try different things. The help section is very good in there as well. So I just want to sort of wrap this up with just a quick note on applying texture to curved surfaces. And we can do this with the Texture Optimizer too. It's a relatively new feature. It allows you to apply texture to a curved surface. The texture is applied as a real geometry and not as a RepTile property. So that has the limitations of, this is now physical structure. So the boundary, partitions, dot shape, and cell densities can be defined in the Texture Optimizer too, just like you do for regular RepTile. There are Boolean subtract and unite options available for making holes or bumps. But because the texture is modeled as real 3D geometry, there can be a limit to the number of features that are applied. Typically, I found around 2,000 features is about where it really starts to slow down and bog down. So I would say the fewer the features, the better. And more texture features, it takes more time. So here's a quick example of setting that up. Here's a curved light guide, the light guide target LED. We're going to apply the texture to the bottom of the light guide. And the way I do that is I come in on boundary and I select surface UV. Enter the name of the surface, bottom, and then click OK. Here's that surface in the surface model view window that opens up. I can then partition that surface. In this case, it's 100 cells, uniform distribution. Instead of sphere, this time I chose flattened cone. It's going to be a hole. The parameters are a height of 0.5, end radius of 0.5, 45-degree cone angle, 0.01 millimeter peak radius, 0.01 meter trough radius. So a little bit different geometry as opposed to the sphere I was using earlier. Here it is in dot preview down here. I can also, just like before, set up the density. These are larger objects compared to before, but my density is 0.25. Click Generate, turn on the dots, and I can see them here. In this case, it's 318 dots. There's a little calculator down here, shows you how long it took to generate. And then to update the model with this, what we can do is we can go to Export, Real Geometries. Before we did Texture, TracePro Texture. This time we're going to choose Real Geometries. And we tell it the surface name. Again, this is bottom. We used that earlier. We're going to do a Boolean subtraction. So I'm going to choose from the Boolean drop-down subtract. Now, because we're doing a subtraction, we need to know what object are we subtracting from. So we enter the name of the object. In this case, it's light guide. Click Export. TracePro will go through and it'll run through and it'll add in, first thing it'll do is it'll add in all of the dots, the feature types, and then it'll go back and do the Boolean subtraction. So you'll see it populating these one by one if you watch the screen, if you're actually doing it. And here's the result. And if I zoom in, in this case I have some overlaps, but we can see we now have this physical geometry applied quite easily to the curved surface of a light guide. So with that, I'm going to wrap it up here. Once again, I'll put out a call for some questions. So anybody that does have questions, please feel free to use the question box in the GoToWebinar control panel, and we'll take a look at those in a few seconds. But to summarize, the TracePro RepTile Property and Texture Optimizer 2 allows really for a fast, accurate, and efficient way to model repetitive microstructures on light guides and backlights. There's numerous options for feature types. It's a quick and easy optimization of RepTile texture patterns on light guides and backlights for improved uniformity. You could also do, like as I said, micro lens arrays. And using the Texture Optimizer 2, you also have the ability to add textures to curved surfaces as real geometry. I'd like to mention, I always mention this at the end of the webinars, for more information or to sign up for our free 30-day trial, because we do offer free 30-day trials of TracePro, please visit us at www.lambdares.com. Our main number is listed there, 978-486-0766. That's here in the US. Or you can also send an email to sales@lambdares.com. So please feel free to contact us with any questions you might have. As I mentioned earlier, this webinar will be archived. We recorded the session here, and we will be putting that up on our website probably within the next day or so, either tomorrow or Monday. And as I mentioned, we will have the recording, the slides, and the examples on there. Basically, I'll give you that light guide example if you want to use that as a test case. So with that, let's go take a look at questions. I'm going to bring Kathy back in in case we need her to add anything in. But first question, I'd like to know what are the equations using in this tool to determine irradiance and error value? Well, the irradiance is calculated using the irradiance map in TracePro. It is basically, the irradiance is the flux on any cell in the irradiance map or any pixel in the irradiance map divided by the area of that pixel. And you can set, in the irradiance map, you can set your number of pixels. I'm not sure on the exact equation that's being used to calculate the error function. I can take a look into that, but basically what it's doing is it's looking at the irradiance in each of the cells in the irradiance map, comparing it to the density of the cells, for the texture, and adjusting the density to adjust the irradiance values. And I think the error function is just the difference between what uniform irradiance would be and what the actual measure, what the simulated value is. But I can take a look into that and try to get back with some additional information. Okay. Another question is, if you want to cover the whole surface with RepTiles, is it possible for the RepTiles to overlap? Yes, you can. RepTiles can overlap. So that's something you may or may not want to watch out for. If it's not, if you don't want them to overlap, at least in the texture optimizer, you can control the density so that you do not get the overlap. In TracePro, you could probably, it's a little more difficult there because you're defining really just the cell, the tile and the parameter, but you could possibly get an overlap there as well. It's always something worth looking at. Do the cells in TracePro act as mesh in ANSYS CFX? That I can't answer because I am not familiar with ANSYS or ANSYS CFX. But basically the cell in the texture optimizer is the partition. How is that surface divided up? So it probably is related, probably analogous to the mesh in an an FEA type program, but really just think of it, how do you divide the space up? Is it uniform? Is it a grid? Then the other, and this one's a really good question here, is how are the microstructures created in real life? Can the designs be replicated in real life? Yes, they can. Let me just exit out here and open up TracePro. My computer's running a bit slow today. I apologize. Here we go. So let me open up this webinar, this light guide here. Oops. So here's the webinar, here's the light guide from today's webinar. And if I switch to a silhouettes view, and I could turn on the RepTile just to show that. So view, display RepTiles, RepTiles and boundary. Takes a few seconds to draw. But if I come down here and I come down to light guide, bottom, and just open up the apply properties, in this case RepTile, there's an option right here to export this. I can click export, and then I have the option to export as either a 2D or a 3D DXF file. And the people I've worked with in the past that have gone and made actual parts from this will export this DXF file, which can then be passed along to the tooling maker or the manufacturer. And it'll show you the the location and the dimensions for the different features. So that's the way to get that from here to the real world. Another question here, can RepTile be used inside of a material along with bulk material properties? Yes, there is at least two of the RepTile properties, block and actually any of the RepTiles, you can set the height of the RepTile from the surface, but block and texture allow you to vary the height. In addition to, say you're doing a texture file, in addition to the XY position, you're able to set a Z value as well. So each feature can be a different height from a surface. And then you're right, you could put that into a material and you could apply different bulk properties to that as well. You could possibly, obviously material property, the RepTile property can have its own surface property, so that may be different. And then you could most likely also add bulk scatter to that as well. So yes, you can do that. It'd be an interesting thing to try, adding the bulk scatter. I haven't done that myself. But yes, one of the RepTile features was added in because somebody was looking to model flakes, metallic flakes inside of a clear coat paint. And we added the block and then the polygon for that. And they're able to add those in, put them in different layers, give them reflective properties inside of, like an epoxy or a plastic material, and look at the results that way. That's the last question I have on the list here. We're actually just past an hour, so I'll put out one last quick call for questions. But while I'm waiting for that, I just want to say thank you everybody for attending today. Also, please, keep your eyes open. We'll be having, other webinars in the future. We're trying to do these on a monthly or bi-monthly basis. Okay, so I don't see any new questions. So with that, I'm going to end today's webinar. Once again, thank you. Thank you to Kathy Johnson here, our U.S. sales manager. She's been helping out in the background. I look forward to talking to everyone in the future. Have a good day. Bye.